Hello, students. So, in this particular assignment, we are going to work on prism and cylinder, I think. Okay, so let's begin, right? So the first question goes like this. The figure shows the sketch of the world's largest gold bar, ooh, right? And that's 45.5 centimeter long. It is a solid prism with a uniform cross section of a trapezium, and straight away they want us to find the volume. Okay, so we need to recall and be familiar with all these formulas. The formula to find the volume of a prism is the area of the cross section times the depth, right? So the depth in this case is 45.5. So area of the cross section, then it brings us to the next thing, right? How to find the area? In this case, the cross section is a trapezium. So we must recall the formula to find the area of the trapezium. So two formulas up here straight away we need to recall, right? So that's but if you have enough practice, you did your diligence and you memorize these formulas, this question shouldn't be too tough, right? So here we go. To find the volume, find the area of the trapezium, and then multiply 45.5. So you can see in my solution, the part highlighted in yellow, that is just the application of the formula to find area of trapezium, which you have actually learned in the previous lesson. Then times 45.5, we have 16,436.875. Good. Okay. Now, with that, we can move on to part 2. Part 2, So here I need to actually give you a caution, because if you're not sensitive enough to such stuff, many students, if you're unaware and you're not careful, it's quite easy to make a mistake here. What am I talking about? I'm talking about the units. You saw that? So the mass of the gold bar is given in the question as 250 kilogram. But the volume of the gold bar that they want you to find is the mass is 200 grams. Okay, so kilogram, grams, they are not the same, right? So we need to actually convert the kilogram to gram so that the two units line up, match up, in order for us to apply the concept of proportionality over here in order to answer this question. So this is a question, a straight up question on proportionality, which is one of the big ideas of mathematics, right? Proportionality. And look at my solution, that's what I have. So we have the volume of the gold bar, that is for the 250 kilogram. We got that from the answers to part 1. And then we are going to just find the proportion, how much is 200 portion compared to 250,000 portion, right? So times 200 over 250,000, where we get these numbers again, well, 200 gram, 250 kilogram, right? So it will be 250,000 gram. Okay, so you divide it out, work it out. Okay, we have 13.1495 cubic centimeter. And that's not all, right? This question, actually, you think about it, the person who said this question is trying to help us in the sense by having another statement and wanting you to leave your answers in terms of cubic millimeters. They are actually indirectly making us think about units, because we need to convert units, we need to think about units. So maybe it helps some students realize, oh, the mass, the gram and kilogram also different units. So yeah, there are lots of tips like this that when we are observant enough and sensitive enough, they are there all to help us, right? So yeah, more training, yeah. Okay, so you work it out, cubic centimeter convert to cubic millimeters, is to multiply by 1,000, so you have the 13,149.5 cubic millimeters over here. Okay. Now the third part of the question goes like that. Now the mass that you want to manufacture, okay, we set it to 200 gram already. So we know the volume, we know the mass. The issue now is the dimensions, right? So after doing some calculation, that's what we have in the diagram, but there's one length that is still unknown that we need to work out. So it is given as X millimeter over there. Yeah, it shouldn't frighten us anymore, right? We know exactly what to do, because by now we know the formula to find the volume, okay, of the this tiny gold bar that we're going to manufacture, right? So we work it out. Okay, in yellow once again is the area of the trapezium cross section. Okay, this time round again, half or 0.5 times the sum of the two parallel lines. In this case it will be 20 plus x, because we have no idea what x is. That's what we want to solve and find, right? Then times the perpendicular height between the two parallel lines, which is in this case 15. Then after that, we multiply by 50 the depth. So that will give us the volume. And this volume is equals to the answer to part 2, which is also the volume that we have calculated from a different source using proportionality. So we work this one out, we simplify this, right? 0.5 times 15 times 30 is 350. Okay, and then after that, to get the value of x, we just take 13,149.5 divided by 375 minus 20, and you should get the value of 15.1. Okay, rounded off to 3 significant figures. Okay, and that's how we can actually apply what we have learned with regards to the volume of prism to answer questions like this. Okay, here's another one with a cylinder there. So well, okay, so we are also quite familiar with cylinder by now, I hope. So it has a solid, it actually has a cuboid and a cylinder attached to it, right? Dimensions are given as the diagram, and they want us to find the volume. So here, the volume, very straightforward. You find the volume of the cylinder, you find the volume of the cuboid, and you add them together, right? So I've highlighted for you, volume of cylinder is highlighted in green, and the volume of the cuboid is highlighted in blue. So pi r square h, right? That's the formula to find the volume of this cylinder. So again, here I need to bring your attention to the radius. Notice that the question actually give us the diameter, which is 12. Okay, so we need to actually train ourselves to be sensitive about such stuff, so that when we want to work it out, we are aware, okay, and mindful that the radius is actually half of 12, half of the diameter. Okay, so if you put 12 there, which some careless, some people who are prone to carelessness may do so. Well, with this with repeated reminders, I hope you actually build up this kind of sensitivity and mindfulness, right? So pi r square h over here, we work it out. So 504 pi plus 3,168 for the cuboid, add them up, 4,750 cubic centimeters, rounded off to 3 significant figures. Okay, now the second part of the question wants us to find the total surface area. So here's quite interesting, because if you look at it, right, from the bottom view, okay, it's just a rectangle from the cuboid. The side view, you get the rectangles of the cuboid all there. Now, if you look at it from the top view, okay, just use your imagination a little bit. The top view, despite there being a cylinder there, is actually still just the rectangle, right? It's still 22 by 18. Because the area of the circle of the cylinder, right? The cross section of the cylinder, when we add it to the area that's exposed on the top of the cuboid, it is still back to the rectangle of the cuboid, right? So that's fine. So the only thing that we need to take note here is that the curved surface of the cylinder. Okay, the cap, the lid, we don't have to worry too much about it. Okay, so here's the total surface area. So 2 times 22 times 18. So 22 times 18 is the front view. Okay, the front of the cuboid. So the front and back, two of them. So we add that down, multiply by 2. And then the highlighted in blue is the curved surface area of the cylinder, right? So to find the curved surface area is actually the circumference times the height, right? So the circumference is 2 pi r, or pi d, right? So 2 pi r is 2 times pi times 6, or pi times 12. They yield the same result, then times 14. So the blue part is the curved surface area of the cylinder. Then the part highlighted in the yellow, that will be the 8 times 22, that will be the side view. Okay. And then we have 8 times 18, the other side view, right? So okay, so again, the bar in red, okay, the top and bottom. Then after that, we have the curved surface area, we have the front and back, left and right of the cuboid. Okay, so all the various parts we need to account for. Okay, and then when you are trying to work out the total surface area, the more complicated the diagram is, sometimes there are many parts. We just need to be mindful, careful. Okay, don't rush. Examine the diagram carefully, look at from all directions, and try to get all the necessary parts down. So you work it out, you'll get 1,960 square centimeter, rounded off to 3 significant figures. All right. Okay, moving on to the next question. This time round, okay, is something different. This time round we have a cuboid. but a cylinder is actually removed. So what happened is in the previous example, when we have a cylinder attached to a cuboid, we call this additive composite figure. This one is subtractive, right? We remove something. But no, the way we look at it will be when we try to solve it mathematically, we'll still use the same idea, same concept. Okay, so we have these dimensions, yep, and we are told to find the volume. So the volume is okay, right? We just need to take the volume of the entire cuboid, which is highlighted in green in this case, length and breadth times height, minus away the volume of the cylinder, which is pi r square h. We already know that. So it's highlighted in orange, right? So you work it out, you have 5,410 rounded off to 3 centimeter figures. Okay, so that's the first part. The second part, they want us to find the area to be covered in paint. Because now what happened is after removing the cylinder, we're going to paint it, right? So how do we do it? Again, there are a few different parts, right? So first, the curved surface area of the cylinder, because it will be exposed now, there is a dug a hole there, right? So 2 pi rh, that will be the 2 pi r is again the circumference times the height, which is 7. So that gives us the curved surface area. And then after that, the cuboid again, front and back, left and right, okay, top and bottom. So all the sides of the cuboid accounted for. So you add all the parts up, you will get 2,140 square centimeter. Okay, right. So with this, I hope you have a better understanding of how prism and cylinders can actually be applied when we are trying to find volume and surface area. Okay, so with this, have a nice day.